So now we're on to question 10 with some financial spreadsheets. So this part A is actually a kind of spreadsheet that we've not seen so far in an actual exam, because remember, this is a specimen paper, not a real one that people actually did. So it'll be interesting to see if this ever comes up. The money is going into a bank account and it's in euros, but she's putting it in pounds, so it's going via an exchange rate. And also the rates of interest are changing every year. So this is what it will look like. First of all, we need to get the interest rates, and they are from 2014 through to 2019, which we can copy and paste from the worksheet. Now there's a complication here that these dates are displayed horizontally. However, when we paste it in, we have to paste it vertically. So you have to pick that option with the arrows and the right angle, which means paste transposing. Whether you would have to do that in a real exam, I couldn't tell you. And it turns it from horizontal to vertical. Now your payment in euros will be your payment in pounds multiplied by the exchange rate. And that's the same formula for all of the payments. Balance for the first period is simply the payment made. Your subsequent balances are slightly more complicated. It will be the previous balance added on the interest. So we need to multiply by the interest rate for that period, which in this case was 4%. So we need to multiply by 1.04, which is why we do 1 plus the 4%, and that's in brackets. And you can already see this is maybe slightly different to other spreadsheets you've done before. We also need to add on the new payment in euros. And once we've done that, we should fill down the formula, and we can see as required we had £41,486 and 5 cents as was requested or required of us in the question. Now don't forget to print your spreadsheets in both value view and formula view. So that's value view. To change to formula view, you can either press Control backtick on the keyboard, or you go to Formulas, click on Show Formulas, and you can see these are all the formulas that we've got in the spreadsheet. So now in part B, Sophie has saved up all of this money and she is going to buy a property, and she can get a 30% deposit on a loan. The 30% is the amount she has saved. The money she is borrowing will be 70% of the total value, and the value of the property will be 100%. So it's a kind of reverse percentages question, and I don't believe that we've had a question like this so far in the exam, so this is something to watch out for. 30% is the value that it gives you, the €41,000. Then we will find 10% and finally find 100%. So first divide by 3 to get 10%, and at the end multiply by 10. So that's what we get if you divide by 3, 13,828.68, and finally multiply by 10, which will be in euros. 138,286.83 euros. Now here's another way of doing it, which is like the other reverse percentages method that we actually had earlier in the exam paper. And this is to realise that to find 30% of a number, you multiply by 0.3. We are given what 30% is, And now we need to get back to the original number. So the opposite of multiplying by 0.3 is dividing by 0.3. So you would do 41,486.05 divided by 0.3, and that will give you the same answer in euros. Simple. So now we're on to part C, which is slightly more conventional, where we have to do a loan repayment schedule in a spreadsheet. The loan amount is for the 70% of the property value. Now that's something I believe we've never had in an SQA exam, with working out the loan amount after you've had the deposit. So that's one thing to watch out for. So the actual loan amount is going to be for £96,800.79. The interest rate was given to us as 2.5%, and we start by just guessing a repayment amount. Now I've said £400. We'll see how that works out. For the repayment, you make an absolute cell reference, which you can do by pressing F4 on the keyboard, or on a laptop it might be function and F4, or you can type in the dollar signs yourself. Interest is always worked out with the round function, so it's the outstanding capital multiplied by the interest rate. Use an absolute cell reference for the interest rate because you want to fill this formula down, and it will be to 2 decimal places. Now if you do this, you should see there's a problem because the interest is more than the repayment, so this loan will never be paid off. So I'm going to go and fix this and change the 400 to 4,000, and then this will work properly. Your capital content, which I'll do again, is equal to your repayment take away the interest. The new balance is equal to the previous balance take away the capital content. Now once you have the second row of the table filled in, you can then fill it down to the rest of the table, assuming that the time column goes down to the appropriate length of time, which is 20 years. In this case is correct. So now we do the goal seek. So you click on the final balance and you want to make this equal to 0. When the loan is paid off, it will have a value of 0. So you go to Data, What If Analysis, and Goal Seek. Set the final cell equal to 0 by changing the cell of the repayment. This may take a while, it may do it quickly, and you get this balance, this payment with the 0.493. Now that's no good, you can't have a fractional part of a penny. So either make it 0.49 or 0.50, doesn't matter which one you do. Now you see the final balance is going to be 7 pence, so we need to adjust this. So one way is to add on 0.07 to the final payment, or another way is to say the final payment has to be equal to the balance plus the interest in order to clear it off. So that kind of works it out automatically, final payment of that. We are asked to find the total payments in both capital and interest content across the entire thing. So we could add up the repayment columns. What I've done here is I've added up the interest content and the capital content. It'll be exactly the same using the sum function, adding up all of these. And we get this £124,189.87 repaid with the Banco de Plata. Now on question 10 part D, we have a new loan from a new bank, Banco d'Oro, which I'm told means Bank of Gold apparently, is the 1.5%. That sounds quite good, but then it's going up to 3.5%, I think this question is potentially slightly confusing. If you look at the third paragraph, it says the loan will be repaid by making level annual repayments at the end of each year. So that looks okay. But then if you look at the second paragraph, look at the first paragraph, it says the level annual repayment is calculated assuming the annual effective interest rate fixed for 25 years. Okay, so now you need to look at the second paragraph. After the repayment is made at time of 5 years, then they change the interest rate. So if they'd worked out the payment based on the 1.5%, obviously that wouldn't pay it off because they're now charging more interest. So what it has to be is that there are going to be two different sizes of payment. One for the first 5 years and then a new repayment following on from that. So let's see how this works. We need to first of all copy over the sheet we did before rather than making it from scratch. It just saves time. So click on create a copy and move to end. We want it at the end. Once you've done that, you can rename the new sheet by double clicking and typing in the new name. Right, so there's a few things that we need to fix. This is now for 25 years, so we need to extend it down to 25 years, which is actually a little awkward because it only goes down to 20, and then you have name and Scottish candidate number in the way. So one way to do it is to insert some new rows, just to push those down. Which one way to insert a row is to highlight a row and then press Ctrl+. Or you could right click and say insert new row. So we want to fill down the formulae for the new table down to 25 years. Now be aware we adjusted the final payment, so we will have to get rid of that formula and use the formula above it, and we won't bother about the adjustment at the moment for the final payment. We'll just do the goal seek. The interest rate, repayment is initially calculated at an interest rate of 1.5%. Loan amount's the same, so now we can do the goal seek as before. Speed this up a bit. Set the value to 0, changing the repayment cell, and it can take a while to settle down. We got there in the end, and then because we're going to be changing it afterwards, we're not going to bother adjusting the final repayment. We'll just round this repayment. You can either round up or round down to the nearest penny. So now we need to make some adjustments for this change in interest rate. So new interest rate is going to be 3.5%. Not 3.5, that would be 350%. So either type in 0.035 or type in 3.5%. We'll also have a new repayment. We'll come to that later. Now we need to be careful exactly which year the interest rate is changing. If you see here, it says after the repayment made at time 5 years. So the new interest rate will be in effect after 5 years. So the first year it's calculated will be between years 5 and 6. So it's going to be after 6 years have elapsed, we're working out the interest on the previous year. That's when the new interest rate is being used. So we will reference the interest rate in the new location. I put it in C8. Don't forget absolute cell reference. And then fill it down. Now we're going to need to find a new repayment, which I started doing here with what if analysis goal seek. I was going to change the original repayment, and then I realised actually that's wrong because I need to only change the repayments for years 6 onwards. So make a cell, new repayment, and in these years reference the new repayment amount and fill the formula down. Also just guess any amount. I've guessed £600, so £6,000, because I figure it will be slightly more. I mean €6,000. So now we should be able to do the goal seek. Set the final balance equal to 0, only by changing only the new repayment, and now we should adjust this. Although it appeared the marking scheme on this paper didn't really seem to mention adjusting the final repayment. It just told you the total repayment, but you should always do this. By the way, the TJ book doesn't, but you have to. It's in the SQA marking schemes. So 6p is still due, so we can find the final repayment by adding the final balance plus the final interest, or we could edit that final payment cell to say plus 0.06 to pay off 6p extra. And I'm saying pence all the time, it's actually euro cents, but it doesn't actually matter. Total repaid is the sum of all the interest and capital, or you could say the sum of all the repayments. And somehow to the nearest penny, it's exactly what's in the SQA marking scheme. So that's reassuring that we did it right. €136,234 and 16 cents. And you should also remember to print everything at the end. So here are all the formulae, in case you missed any as well. And make sure you hand this in at the end, because obviously if you've done the question, you don't want to lose your marks. You lose your marks for it, which apparently has been quite a common thing. That people's printing has just gone missing. So that's us done with this part. So finally, in part E, we have to state an advantage and a disadvantage of Sophie taking out the Banco d'Oro mortgage instead of the Banco de Plata mortgage. Well, one advantage we could see from part D is that initially her repayments are less. And that was both because of the lower 1.5% interest rate and also the loan being over a longer time period. That is the only advantage. The disadvantage, however, would be that she is paying back more overall, and also she has to pay back over a longer time period, although we just need to state that she is paying back more. So it's not a deal that is particularly to be recommended. And that's finally the end of this question.